Hi, this is going to be lesson 5.2, finding the percent of a number. So let's get started. Okay, finding the percent of a number. Our objectives today are I can find the percent of a number and I can apply the percent to real life situations. And our standard that we're working in are two of them, EE2 and RP3. So EE2 says understand that rewriting an expression in different forms in a problem context can shed light on the problem and how the quantities in it are related. And then understand proportional relationships to solve multi-step ratio and percent problems. So today we're focusing on the percent. We've already done a lesson on ratios. So we're going to talk about finding the percent of a whole. Finding the percent of the whole means finding what percent, let me put myself under here, finding what percent a part is out of a whole. So for example, what is 25% of 80? We're looking for the part that is 25% of 80. 25% is actually 1/4 of 100. So we're actually trying to find 1/4 of 80. So how do we do that? Well, there's two steps. Step one, we're going to change the percent to a decimal. And you did this in the last lesson. If you forgot how, you can go back and watch that lesson, lesson 5.1. But we're going to take 25%. We're going to assume the decimal is after the number. And what are we going to do? We're going to move 2 spots to the right, to the left. Not right, but to the left. Right meaning correct, but left. So we're moving 2 spots to the left, placing our decimal there. So we have now changed 25% to 0.25. And then step 2, we're going to multiply the decimal by the whole. So the whole is 80. We only have 2 numbers in our problem. So let's do that. So 80 times 0.25. So we're going to take the 5 times the 0. That'll give us 0. And then we're going to take the 5 times the 8. That will be 40. We're going to write the 40 there. Then we're going to do 2 times the 0. We're going to put an X here. That's not a times sign. That's an X because we have to hold our place. And we're going to start our answer under the 2 because now we're multiplying by the 2. So I put an X there to hold places. Some people put a 0. Some people just don't put anything. But if you don't put anything, remember that you have to move over 1 so you're in line with the 2. So 2 times 0 is 0. And then we do 2 times 8. And that is 16. Now we add our partial products, 400 and 160. So 0 plus x is just 0, right? 0 plus 0 is 0, and 6 plus 4 is 10. And we're going to carry our 1. And then 1 plus 1 is 2. And now notice that we have 2 numbers after the decimal here. So we're going to have our answer down here with 2 numbers after the decimal. So we assume the decimal starts at the end, and we go 2 places to the left and plug our decimal in right there. So that'll be 20.00. We can drop the 0.00 part, and the answer is 20. So 25% of 80 equals 20. That should be 1/4 of 80, which it is. If you count by 20s, 20, 40, 60, 80, there's 4 20s in 80. This means that the part 20 is 25% or 1/4 of the amount of the whole, which is 80. Okay, let's see another one. So what is 5% of 120? Same 2 steps. Step 1, change the percent to a decimal. So we have 5%. The decimal is assumed to be after the number. And we have to go 2 places to the left. 1 spot, 2 spots. And we have to fill in our empty space with a 0. And now we put our decimal. So 5% is equal to 0.05 as a decimal. Now we multiply by the whole number, 120. So 120 times 0.05. So 5 times 0 is 0. 5 times 2 is 10. We put down the 0 and we carry the 1. 5 times 1 is 5, plus 1 more up here is 6. Now we do this column. So we have to put an X in here because we want to start under the 0. So 0 times 0 is 0. 0 times 2 is 0. And 0 times 1 is 0. Don't add this 1 this time because that was from the first set with the 5. And by the way, when you see that it's 0 for everyone, you really don't have to do this row because they're all zeros and you can see that. But if you don't recognize that, then put the zeros in. And then add that together. So 0, 0, 6, and 0. And we have to have 2 numbers after the decimal. So it starts at the end. We go 2 spots to the left. And that's where we're going to put our decimal. So that's 6.00. We can drop the 0 in front of the 6 and the 2 zeros after the decimal point. So it's really just 6. So 5% of 120 equals 6. This means that the part 6 is 5% of the amount of the whole out of 120. And if you kind of think about it, does that kind of sound reasonable? We know that a percent is always out of 100. And if you have only 5% of 120, it's not going to be a very big number, is it? Because what is 50% of 120? Right, 50% is 60, right? So 5% is way less than 50%. So it has to be way less than 60, doesn't it? So 6 makes sense. So sometimes ask yourself, does my answer make sense? Okay, next one. What is 85% of 940? Step 1, change the percent to a decimal. The decimal is assumed to be after the percent number. Move 2 to the left. Put the decimal there. And now we multiply the decimal by the whole number. 940 times 0.85. Multiply 5 times 0 is 0. 5 times 4 is 20. Carry the 2. 5 times 9 is 45 plus 2, 46, 47. Now we do the 8 times each number. We have to start our answer under the 8. 8 times 0 is 0. So I'm going to put my X there and I'm going to put 0 under the 8. And I'm going to do 8 times 4. That's 32. I'm going to put down my 2 and carry my 3. So here I carried my 3. I crossed off my 2 from the first carry because that was old and we don't want to get mixed up and think we have to carry 2 when it's really 3 this time. So 4 times 8 is 32. Put down the 2, carry the 3. Now we do 8 times 9. That's 72 plus 3 more, 73, 74, 75. And then we add our partial products. 0 plus x is 0. 0 plus 0 is 0. 7 plus 2 is 9. 4 plus 5 is 9. And 7 plus nothing is 7. We have 2 numbers after the decimal, so we have to move 2 spots to the left. So our answer is 799. We can drop the 0.00. 85% of 940 equals 799. This means that the part 799 is 85% of the amount of the whole, which is 940. Ask yourself, is this reasonable? Well, 85% is really close to 100%, which is all of it, right? So it should be a pretty big number. It should be pretty close to 940, right? So 799 makes sense. Okay, you get to try some of these. Pause the video, do the questions, and then come back. Okay, welcome back. Let's continue. Applying percent to real life situations. So percent is something that you actually will use in real life quite frequently. It's something that everybody should know how to do. So here's a word problem. During a period of 30 working days, Deborah was late 80% of the time. How many days was she late? Well, think about it. Is this going to be a fairly big number or a fairly small number? Is it going to be closer to 30 or closer to 0? Yeah, it should be closer to 30, right? Because 80% is pretty close to 100%, which is all of it, which would be 30 days, right? So she's been absent or late, 80% of the days. So you need to find 80% of 30 days. Same steps, change the percent to a decimal. We have 80%. We're going to move 2 to the left. And then we are going to multiply by 30 days. 30 times 0.80. 0 times 0 is 0. 0 times 3 is 0. And you could skip that step if you see that it's both zeros. But then remember, if you go to the right to the 8, you got to start it under the 8. Put X there. 8 times 0 is 0. And 3 times 8 is 24. Add our partial products, 0, 0, 4, 2. We have 2 numbers after the decimal. We move our decimal 2 places to the left and we get 24.00 or 24. So out of that 30-day working period, Deborah was late 24 days. And that makes sense. It should be pretty close to 30, right? Because it's closer to 100% than it is to 0%. Okay. Let's look at another one. The Smiths spend 33 1/3% of their take-home pay for food. If they take home $504 a week, how much do they spend each week for food? So it'd be somebody who's trying to do a budget at their house. You may want to do this one day. So you're going to want to know, well, what percentage of my money am I spending on grocery bills every week? So we're going to do step 1. We need to find 33 1/3% of 504. But before we can do step 1, we have an issue, right? If we wanted to try to put this in a calculator, we don't know what 1/3 is, right? So we have to change it into a decimal. How do we do that? Well, if you wanted to do it the long division wise, you would put 1 on the inside and 3 on the outside and see what decimal you get. Well, you can't do that. So you put a decimal point and a 0. Put the decimal point up here. 3 goes into 10 3 times. 3 times 3 is 9. 10 minus 9 is 1. I can bring down another 0. And now I have 10 again. 3 goes into 10 3 times. 3 times 3 is 9. 10 minus 9 is 1. And then I can add another 0. And you can see what's happening. I'm going to get 0.33333333, never ending 0.33s, right? So we're just going to round it to 0.33. So 33 1/3 is going to be 33.33. If you're doing this on a calculator, you would type in 1, the divided by sign, the 3, and then you would hit the equals and you would get some display of 0.33333, and it would probably round the last number to 4 because the display would end. So it usually rounds the last number. So you would get 0.3333334. But the answer is it's a repeating 0.33. So we're going to change it to 33.33. So it's approximately 33.33. Why did I say approximately? Because it's a repeating 0.33333. So it really never ends. So it's just approximation. Now we can do our 2 steps. First step, change the percent to a decimal. 33.33. Okay, we've got our decimal here this time. It's not at the end of the number. So we still move it 2 to the left from where it's at. 1, 2, put our decimal there. So now it's going to be 0.3333. And then we're going to multiply by the whole number, which is the whole number in our problem. Right, 504. So we're going to put the 0.3333 on the top because there's 4 digits here and there's only 3 digits here. So we have to put the number with more digits on top. And now we multiply. So I don't think I went through and did it step by step. 4 times 3, 4 times 3. Maybe I did. Let's see. 4 times 3, I guess I did, is 12. Carry the 1. 4 times 3 is 12. Carry the 1. 13. Carry the 1. 4 times 3 is 12. Carry the 1, plus 1 is 13. Carry the 1. 4 times 3 is 12 plus 1 is 13 more. I just didn't put the arrows in this time. The second row is all going to be zeros, right? Put your X there, and then you put 0 times 3 is 0, 0 times 3 is 0, 0 times 3 is 0, 0 times 3 is 0. If you want to eliminate that row, you can, but just remember if you start with the 5, you're going to make sure your number goes under the 5. So 5 times 3 is, 2 X's there, 15, carry my 1. 3 times 5 is 15 plus 1 is 16, carry my 1. 3 times 5 is 15 plus 1 is 16, carry my 1. 3 times 5 is 15 plus 1 is 16. I didn't have to put a separate number up here this time just because they were still all ones. But normally you might have to cross off these ones and put the new number up here that you're carrying. But they all happen to be ones again. So, okay, now we add that up. So 2, 3, 3 plus 5 is 8. 3 plus 6 is 9. 1 plus 6 is 7. And then we got 6. And we got 1. Now, how many places after the decimal do we need? 1, 2, 3, 4 numbers after the decimal. Put our decimal at the end of the number and we go 4 spots. 1, 2, 3, 4. Our decimal is going to get put right there. Hopefully I put the decimal there. There it is. Okay, so our answer then, since we're dealing with money, you can't have $167 and 9.9832, right? So we're just going to leave this and drop these other two numbers. We could round this up, but no, because this is a 3, so we're going to keep it 98. So the answer is, and my black box is at the bottom there, the Smiths spent $167.98 for food. And that seems about right. It should be under half, and half of 504, because that'd be 50%, right, is 202. So it should be under 202, and it is. So it is reasonable. Okay, let's look at another one. To make a profit, stores mark up the prices on the items they sell. Markup means they charge you more. A sports store buys skateboards from a supplier for $35. What is the retail price? Retail price means the store price after a 42% markup. So stores will buy something cheaper from their supplier, person that makes the skateboards, and then they will sell it in their store for more. Why would they do that? Because they make a profit, right? They're in business to make money. That's their income. So they're going to charge you more. How much more are they going to charge you than $35? Well, they're going to charge you 42% more. So if one day you're a business owner and you want to say, how much profit am I going to make? You can figure out how much you want to mark up your products. You'll be using percent a lot. So what do? Well, we have to find 42% of $35. So we're going to change the percent to a decimal. You should be really good at this now. 42% is what as a decimal? Move the decimal 2 to the left, and you get 0.42, right? Okay, and then we're going to, step 2 is multiply the decimal by the whole number 35. So 35 times 0.42. And I just put the answer in here, I think. Yes, I did. Did I? Yes, I just did. Because I figured you know how to multiply now, saving a little bit of time. So $14.70 is the markup. If you don't believe me, you can do the math. 2 times 5 is 10, carry the 1. 2 times 3 is 6, 7, and then 4 times 5 is 20. You can do the math and do the partial products. But if you want to use a calculator, just type in 35 times 0.42 and then the equals, and you'll get $14.70. Is that the answer to my question? What is my question? Let's look at it. Let me change colors here. My question is, what is the retail price, the selling price, after the markup, right? After 42% markup. Is $14.70 how much she's going to sell the product for? She's going to sell the skateboard for less than she paid for it? That doesn't make sense. I have another step, right? The $14.70 is how much more she's going to charge. So we have to do what? We have an extra step. We have to add the $35 supplier cost plus the $14.70 markup. And that'll give us how much she wants to sell this skateboard for. So if we add that up, 0 plus 0 is 0, 7 plus 0 is 7, 5 plus 4 is 9, and 3 plus 1 is 4. She will charge $49.70 in her store for the skateboard. So when you go in to buy it, you're not going to pay $35. You're going to pay a 42% markup. You're going to pay $49.70. And your store owner is going to get a profit of $14.70. However, your store owner is probably not going to get a $14.70 profit off that because he or she has to pay for the lights, the heating, the store rental, the people that work at her store. So she's really not going to probably make $14.70 off of that. However, the retail price you're going to pay is $49.70. So if you are the buyer, you only care about the retail price. If you are the store owner, you're going to care about how much profit you're going to make. Let's look at another one. To make a profit, stores mark up the prices on the items they sell. Okay, we already did this one. Is this the same one twice? Let's see. Oh no, let's take a look at another way to calculate retail prices. So if we go back, let me just go back to slide 8 for a minute. On this one, how many steps did we have? Let's get back to that. We had 2 steps, right? We had, after these green steps, we had the yellow step, we had the markup, plus we had to add that $35 in. So we had an extra step in there. We had to add in that extra money. And you might be working on a test and you might forget, oh, I have $14.70, that's the answer. And you might forget to add the $35, right? Especially if you're doing a multiple choice test, you know I'm going to put a choice of $14.70 as the answer. And if you're rushing through the test, you're going to go, oh, that's the answer. And you're going to forget to add it. But there's a better way. You can do the shortcut method. So that's why this slide is here now. Another way to calculate the retail price is realize that the retail price, the selling price, is going to be 100% of the supplier's cost, right? $35 plus the 42% markup. So you just add 100 plus 42 and you get 142%. That's how much she's going to charge, or he, the store owner. So then you can change 142% over to a decimal. So change 142% to a decimal. That would be 1.42, right? You're going to move 2 to the left. And then you're going to multiply by $35. So 1.42 is your decimal. And then you're going to multiply by 35. If you did that on a calculator, you do that by hand, you will get $49.70. You have just eliminated that extra step of adding the $14.70 to the $35 because you multiplied by a percent over 100. Okay, so you can do that if you are so inclined. Let's see another one. Let's look at a markdown question. Oh, one more step. Using this method eliminates having to add the markup to the supplier cost. Okay, we already talked about that. Okay, next one is a markdown. A discount store marks down all of its Christmas merchandise by 20% off the regular selling price. Find the discounted price of decorations that regularly sell for $16. You're going to use this a lot as a buyer. You're going to go to the store and you're going to go after Christmas and you're going to want to buy all your wrapping paper and Christmas stuff at a discount. You're going to want to know, how much am I going to pay? So markdown is taking money off. It's selling something on sale. So this one is selling for $16 regularly, and now it's 20% off because it's after Christmas. How much are you going to pay? Well, you need to find 20% of $16. So step 1, change the percent to a decimal. You should be really good at this. What's 20% as a decimal? I hope you said 0.020 out there. So move your decimal 2 to the left. 0.20. Multiply that by what? Yeah, 16. So 16 times 0.20. I'm not showing the actual steps of doing that. I'm just saying the answer is going to be $3.20. Is that your answer? Are you going to buy that item for $3.20 if it was originally 16? No, right? That's not how much you're going to pay. That's how much off you're going to get. So what do you have to do? You have another step, right? So $16 was the original cost. The markdown was $3.20. That's how much you're taking off of the selling price. So you're going to subtract. So 16 minus 3.2, and I'm actually going to do this one because I want you to see how to subtract with zeros. 0 minus 0 is 0. Now you can't take 2 from 0, so you borrow from the 6 and make it a 5. The 0 becomes a 10. 10 minus 2 is 8. You keep your decimal there. 5 minus 3 is 2. And 1 minus nothing is 1. So $12.80. I'm going to hit clear because it's going to show up on my thing when I click on it. There it is, $12.80. That's how much you're going to pay for the Christmas decorations after a 20% markdown. Don't forget to do that step because you know I'm going to put in there a question and you're going to have an answer choice of $3.20 and you're going to be like, that's the answer. No, it isn't. $12.80 is the answer. So the discount price is $12.80. Okay, let's see a shortcut. Same question. So here's another way to calculate it when you have a discounted price. So realize that the discounted price will be 100% of the original cost minus the 20% markdown. The original cost is 100%, $16, but you're going to take 20% off. So can't you subtract 100 minus 20? Of course you can. 100 minus 20% is going to give you 80% of the original price. That's how much you're going to pay. Thinking of it backwards, right? So then you're going to change 80% to a decimal and multiply by 16. So 80% as a decimal is 0.8, and you're multiplying that by 16. If you do the math, you'll get $12.80. You just eliminated the step. So using this method eliminates having to subtract the markdown from the original price. So in summary, if you mark up, you add the percent to 100. If you mark down, you subtract the percent from 100. Okay, I might actually write that for a moment here. Let's make a nice big blank. Put that in there. Make it nice and big here. If, okay, why isn't that typing there? If you mark up something, you add the markup percentage, to 100%. Okay, and then change to a decimal and multiply by the price. If you mark down something, you subtract the markdown percent from 100% and then change to a decimal and multiply by the price. Okay, keep that in mind. That's a helpful shortcut. If you don't remember how to do that, that's okay. You can just do it in 2 steps. Okay, I believe you have a chance to try this, and I will see you back in a moment. Okay, welcome back. We're going to focus on some higher order thinking. Okay, stick with me on this one. This is for all you advanced kiddos out there. And if you say, I'm not advanced, don't check out, because you're probably going to know exactly what's going on here. At Danielle's clothing store, if an item does not sell for 8 weeks, she marks it down by 15%. She's going to reduce the cost. Why would a retailer reduce the cost of something? Well, if it doesn't sell, she wants to get rid of it. She's going to start marking it down. We used to have a lemonade stand. We'd sell lemonade and brownies. And at the end of the day, we wanted to get rid of the brownies and the lemonade. So we'd say sale price and we'd charge less. Okay, if the clothing still doesn't sell, Danielle is going to mark it down an additional 5% each week until she can no longer make a profit. Then she donates it to charity. So I made a nice little chart for us here in just a minute. Raphael wants to buy one of Danielle's coats that originally was priced at $150. However, Raphael can only afford to pay $110. So if Danielle paid $100 for the coat, right, she's going to donate it once she can no longer make a profit, right? So after it gets lower than $100, she won't be making a profit anymore. So she's just going to give it to Goodwill. So during which weeks should Raphael buy the coat for $110 or less, right? Because he has $110. He doesn't want to wait too long because then she's just going to get rid of it and take it to Goodwill. So he wants to buy it between $110 and $100, right? So I made a chart for you. So between weeks 1 through 8, she's not going to mark it down at all, right? She's going to hope to sell it for $150. So the retail price during that time will be $150. What's her discount during those first 8 weeks? Nothing. She's not going to mark it down. So what's the discount amount? Nothing. She's not going to change the price. What's the new price? Well, it's the same as the old price because she's not taking any money off, right? And let's compare that to what Raphael wants to pay. So $150 is greater than $110. So Raphael's not going to buy it. Too big, too much, cost too much. So, but week 9 now, that's going to start where Danielle's going to reduce it 15%. So what's the retail price? It starts at $150. She's going to discount it 15%. So then you would go 0.15 times 150. That'll show us how much she's going to discount it. She's going to discount it $22.50. You want to use the shortcut method, you would just do 100 minus 15, and that would be 85%, and you would do 150 times 0.85, and you would get the new price right away. But I'm doing the extra step not to confuse you. So the discount amount is 150 times the 15%. She's marking it down, $22.50. What's the new price going to be? Well, it's $150 minus how much she marked it down, $22.50. The new price she's going to sell it for on week 9 is $127.50. Let's compare that to what Raphael wants to pay. $127.50 is more than $110, the amount Raphael can pay. So he's going to wait longer. He doesn't want to wait too long because if it gets down to $100, she's going to get rid of the coat. Let's look at week 10. So the price starts at $127.50 at the beginning of week 10. It's been marked down already. Now she's only going to discount it an additional 5% each week. So that's the discount now, 5%. So the discount amount is going to be $127.50 times 0.05. We changed percent to a decimal, and we get $6.38. That's how much she has discounted it on week 10. So what's the new price? $127.50 minus $6.38. She will now have a new selling price of $121.12. And I hope you're using a calculator for this because that's a lot of math. Now we're going to compare that to what Raphael wants to pay. So the price is $121.12, and he has $110. It's still too high for him. Let's go to week 11. So on week 11, our starting price is $121.12. I encourage you now, pause the video and see if you can fill out the rest of the chart. Okay, hopefully you filled out the chart. You pause the video and then you can check your work. She's going to charge a 5% discount. She's going to discount at 5% again for the rest of the weeks. So 121.12 times 0.05. She's going to discount at $6.06. The new price will be $121.12 minus $6.06. Her new price is $115.06. Let's compare that to Raphael's cost or price that he wants to pay. $115.06 is still more than $110. He's getting pretty close though, isn't he? Let's look at week 12. Now the price is $115.06 at the beginning of the week. She's going to discount it 5%. $115.06 times 0.05 is equal to $5.75. So $115.06, the price minus the discount of $5.75 equals $109.31. Compare that to Raphael. $109.31 is less than $110. Raphael should now buy the coat because it's less than $110. There we go. If you wanted to figure out week 13, I believe you would find out that the cost would be probably less than 100 and she would donate it to Goodwill. Let me just do it for you on my calculator here. $109.31 times 0.05. It would be a $5.47 discount. So 109.31 minus $5. And what did I say? 71.41 cents, I think. Well, actually, he could still maybe buy it on week 13. It still would be on a little over $100. So maybe he'd want to wait to week 13 because then he would get a little bit of a better deal. But someone might buy it, so maybe he's best to buy it just at week 12. So Raphael should buy the coat at week 12 because the discounted price will be under $110. That was a fun problem, wasn't it? I liked it. I liked that problem. Okay, I'm actually going to have you try a problem like this, not with so many rows in the columns, but give it a try. I know you can do it. Okay, welcome back. Your homework is on Google Classroom, and I will say goodbye to you, and I will see you next lesson. Bye.